Hello everyone, today is day 45 of solving a LeetCode problem every day, and today I'm going to be solving longest repeating character replacement. So, you are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. So you must return the length of the longest substring containing the same letter you can get after performing the above operations. So for example 1, our input is AB and our output is 2, or sorry, our k is equal to 2, which means we can change 2 of these characters in the string, and our output is 4 because we can either change 2 A's to B's or 2 B's to A's. Now here we can only change one character, and our output is 4 because we have A over here, so we can replace this 1B with an A and get a substring of length 4, or you can do the same thing here and replace this 1A with a B, and we have a length of, or a substring of length 4. So the way I'm going to solve this problem is by using the sliding window technique. So essentially you're going to have a left and right pointer that keeps track of whatever substring we're looking at right now. And what we're going to do is we're going to keep track of the count of characters within the substring. Like for example, within the substring, we have 3 A's and 1 B. And what we can do is we can subtract so for example, we have 3 A's and 1 B here. That means that the max amount or the largest amount of characters or of a unique type of character that exists in this substring is an A. So we have 3 A's. There are more A's than B's. So what we can do is subtract the length of this substring by whatever the most characters there are in the substring. So for example, the length of this substring is 4, and we can subtract 3 A's by the total length of 4. And now we know that there's one character within the substring that isn't basically whatever the largest amount is. So for example, we have 3 A's, we subtract 4 by 3, and we're left with 1. So we know that there's one character within this substring that doesn't match up to the rest of the A's. So what that pretty much means is we know that k is equal to 1. We know that there's one character in here that doesn't match up to the rest of the characters. So we know that within this string, we can perform one replacement, and this would be a valid substring right here. So that's how we can get to that output of 4. So what we're essentially going to do is we're going to keep increasing this window, and we're going to keep checking if the difference between the count of the characters is greater than this. And if it's not greater, we can just keep making the substring bigger. However, for example, at this point right here, we have a substring of length 1, 2, 3, 4, 5. And the largest amount of characters we have is 3, so 3 A's. And 5 minus 3 becomes 2, which is greater than k equals 1, which means that we can now make our window smaller and perform the same calculation with it within this window right here. So now the max amount of characters that exist is 2. So what we can do is subtract 4 by 2, and that's 2, which is still greater than k. So we increment the left pointer once again, and now we have a substring of length 3 with the greatest amount of unique characters existing being 2. So 3 minus 2 becomes 1, and we have the one character here that we can just change. And yes, I mean, that's pretty much how we're going to do it. We're going to keep performing this algorithm until we get to the end, and we're going to keep track of whatever the greatest length of a substring that we have reached. So the first thing we're going to do is initialize our hash map that's going to store the count of each character. We're going to initialize our left pointer, and we're going to also initialize our response, which is going to be initiated as 0 to start out. So then we're going to say for r in the range of length s, where r represents our right pointer, every iteration we're going to update the count. So we want to say count.get sr, or return the default value of 0 if it hasn't been initiated yet, and add 1 to that. So we're pretty much just updating the count here. And then here we want to check if right minus left plus 1 minus the max of whatever the values are right now is greater than k. Does this need, that's out, okay, out here, so k. So here we're checking, so right minus left plus 1, this gives us the length of our current subarray or substring, sorry. So if we have like, our left pointer is at 0, our right pointer is at 3. 3 minus 0 is 3, plus 1 gives us our length of 4. Then we subtract whatever the max of the count dot values are. So if we're looking at this substring right here, the max would be 3 since there are 3 A's. Then we check if this is greater than k. And if it's greater than k, that means there is more than k elements that we need to replace to maintain only one unique character in this substring. So what we're going to do is, again, we're going to maintain our count dictionary. And we're just going to subtract 1 from this since we're going to increment our left pointer. Then finally, we can just set our response to be the max of either whatever response currently is, or we can recalculate whatever the length of our current substring is and check if it's greater than response. And if it is, then we set it to that instead. And then finally, we just return response. If we run this, it's accepted. So the space complexity of this solution is going to be however, so it's going to be linear since we're storing however unique characters there are in this count dictionary. And then the time complexity of the solution is going to be O of, let's say, n times m, where n is the length of the string and m is the number of unique it's the number of unique characters within this count hash map, since here we're calculating the max of count dot values. And yeah, so one thing I want to add is there's a way to actually make this solution even more optimized. And the way we can do this is by keeping track of whatever our max, so like whatever the max amount of characters in the string is. Like for example, if we have AABA, there's no need to recalculate this max.count values every single time. We can just calculate this once as we're traversing through the string and then just reference it. So instead of like, because this is going to take m times where there's m unique characters, because we're iterating through the dictionary and grabbing all these values out of it. But instead, the whole idea is we can just keep track of the max count in this variable right here, and this would turn this into a constant time operation instead. So what we're going to do in here is we can say max f is equal to the max of max f, or count of SR, which is the current character that we're at. And then we can just reference max f instead here. So if I run this again, this will also work. So one thing I want to mention about doing it this way is it's going to be more efficient, but it might be a little hard to wrap your head around because, for example, let's say we're looking at this string right here. So our max f is going to be equal to 3, but then once we get to here, so our max f is still equal to 3, but here we're subtracting, so we're going to subtract 5 minus the 3 A's, and we see that and that gives us a 2, which is greater than our k. So we then increment our left pointer here. So we have AB, and we do the same thing, which is 4 minus 3, and that's going to be 1, which is not greater than k. So this is fine. But what I want to mention here is now we earlier had 3 A's, which matched up to whatever our max f was, but now we have 2 A's, and we actually don't have to update our max f. We can just leave this as 3. And the reason why is because our response is never going to update unless max f gets bigger. So like with this, we get to AB, and then, we see the string is valid, so we don't have to keep going with this. So now we increment our right pointer and we look at this string right here, and now we kind of get to the same thing again. Um, so our max f stays at 3. So we do the same thing. This length is 1, 2, 3, 4, 5. We subtract 5 by 3, which is 2, which is greater than k. So we increment our left pointer and kind of get to here again. And now we see this string is valid. So I guess the point I'm trying to make is this response right here is never going to change unless, for example, we were to maybe get like a fourth B. Like if there was a fourth B, like after this last B here, then our max f would become 4. And in that case, then the length of this substring right here can be 1 greater, which would make this response right here 1 greater. So, I mean, I'm not going to get into too much, it's kind of difficult to explain just because, it's even kind of hard for me to wrap my head around it, or like, especially the first time I kind of looked into that solution. But yeah, that's definitely something to keep in mind. But yeah, that's my solution for the day.